And we're back to this episode. And yes, today we're going to talk about counting in different bases. So, counting is like an extremely simple stuff that you can do in math. Yes, like counting is like very simple, right? So, try this. Count from, let's say, okay, what's your favorite number, but not too big, not too much.
1.
Okay, we need a higher number, like more than 10.
Oh, more than 10. 15.
Okay, so try to count from 0 to 15.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15.
Okay, so in this case, we just count normally in this case, but instead of like calling 10 10, try counting like 1 0, and then 11 is 1 1, and then 12 is 1 2. So maybe try that again from 0 until 1 5.
0, 1, right?
Mm-hmm.
1, 1.
No, no. 0, and then 1 2 3 4 5 6 7 8 9, and then instead of 10, you say 1 0, right? That's the way how we normally write it.
Oh, okay. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and 1, 5.
So yes, so this is what we normally know as base 10, because in this case we only have 10 numerals or 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when you want to say 10, you do not have a symbol for that. So instead, you will need a new place, like you have the ones place and then the tens place and all that stuff, right? Okay,
Yep.
so let's go a little bit weirder. So let's say we don't have 10 numerals. Let's say we only have 5 numerals. So we only have 0, 1, 2, 3, 4, right?
Okay.
Okay, so try to count in base 5, but try to reach number 15.
Base 5? Like 5,
Yes.
10, 15? Or
How should I say this? Okay. The same number can be written in different bases, right? But here how it works. Like in normal base 10, we know our ones place is 10 to the power of 0. So that's how many ones we have. For the tens, we have like 10 to the power of 1. So that's how many tens we have. For the hundreds, we have 10 to the power of 2. That is how many hundreds we have, right?
yes.
Now, it's the same thing, but this time our base is 5. So our ones place is how many 5 to the 0 we have. The tens place will now become 5 to the power of 1. That's how many 5s we have. And then the hundredths place will just become 5 to the second power, which is like how many 25 do we have? So in this case, the number you have picked, 15, which is actually perfectly, we have 3 5s, yes?
Yes.
So try to do this. In base 5, count from 0 to 30.
So 0 to 30.
Yes.
Uh 0, 1.
Yes.
Okay. And then 2, 3, 4, 5.
But in base 5, we do not have the numeral 5. So in this case, you will need to introduce the 10th place.
Mm-hmm.
So instead of 5, you will have 1, 0, right?
So instead of 5, you have 1, 0.
Yeah.
Oh, okay. So it's 1, 2, 3,
because
4,
okay,
1, 0?
yes.
Okay.
Because here's the main idea. In normal base 10 counting, like our normal life, once a digit has reached 10, we do not have like a symbol for the number 10 to squish in that digit, right? What we
Mm-hmm.
do is we carry the 10 to the next digit.
Mm-hmm.
Now, it's the same situation over here. In base 5, we do not have the symbol 5. So we carry the 5 to the next digit. So if we start from 0 and then 1, 2, 3, 4, and then the next number would be
1, 0.
There we go. Now continue.
1, 1.
Yes.
1, 2.
Okay, good.
1, 3.
Yes.
1, 4.
Yes.
And then 1, 5.
But do we have 5
No.
in this case? So instead of 1, 5, you will carry that 5 to the next one, right?
Yes.
So instead of 1, 5, you will have
1, 0?
No. 1, 5. You carry the 5 from the ones place to the 10th place, right?
Mm-hmm.
So 1 becomes
0.
no.
Oh my gosh.
You know, like the part. Okay, if we go back to like normal base 10 a little bit, let's just say we start from 38, and then you have 39, right? Which is 9, right? And then you have 310. But in normal base 10, we do not have the symbol for 10. So we carry the 10 and put it into the 10th place, and 3 becomes 4. So instead of 3 tens, we have 4 0, right? So if we come back here to base 5, you got stuck at 1 5. Now it's almost the same situation. We do not have the number 5. So in this case, we carry the 5 to the next place. And then the next place will increase by 1, right?
So it's 2?
Yes. So we have
2, 0?
There you go.
I'm a genius.
Okay, now keep on going. 2 0 and then
2, 1. 2, 2.
Yes.
2, 3.
yes.
2, 4.
And then
3, 0?
there you go. You have reached your goal. There you go. Achievement
Look at me now,
unlocked.
Mom.
So if you want to like go even higher, of course you can go 3 1, 3 2, 3 4, and then 3 3, and then 3 4, and then instead of 3 5, we have
3, 5, we have 4.
So it's 4 0, right?
4, 0.
And then you keep on going. So what you can imagine is like, if you remember back in your old days, like when you drive your car, you have that odometer just to keep counting like how long you have driven, right? You have that like spinning clock thing, right? And then every time when the first one does a full rotation, it just kicks the next one, right? Now,
Yes.
it's almost the same situation over here. It's just that in base 5, you only have 5 numbers on the wheel. 0, 1, 2, 3, 4. And when it does a full rotation, it kicks the next one. Right?
Yes.
Okay, so now we are ready for one of the most important base, and this is why we need this.
Wow.
So
A clock.
this this is what I call bOwOnary, but this is actually one of the things that it will help you count in base 2.
Okay.
So yes, in base 2 or binary, you only have 2 numbers, 0 and 1. So in binary, the main idea is once you count to 2, you will carry it to the next digit. Okay, so you want to give it a go to count on binary in this case? Let's just say,
I can give it a try.
okay, try to count to 10 in binary from 0. So 10 in binary is 1010. So let's give it a go. Let's see if we can start from 0.
Okay. 0,
Mm-hmm.
0, 1.
Okay.
1, 1.
1, 1 is 3. So just in case, just to be clear, in binary, okay, in normal base 10, we have the 1 place, 10 place, 100, and so on. 1 place is 10 to the 0, 10th place is 10 to the 1, and then 100 is 10 to the 2, right?
Yes.
And then in base 5, which is the one that we were previously in, we have 5 to the 0, 5 to the 1, 5 to the 2, right?
Yeah.
So in binary, each digit is actually the increasing power of 2. So the ones place in binary is 2 to the 0, which is 1. And then 2 to the 1 is 2, and then 2 to the 2 is 4. 2 to the 3 is 8, and so on. And so this is why, if you take this thing, and then let's just say I activate the ones place. So in this case, the furthest right bulb just represents 1. So we have 2 to the 0, so that's 1. Now, if I were to turn that off and then switch to the next place, we have 2, which is to the 2, which is 4. So we also have this one over here, and then 2 to the 3rd, which is 8. So basically, in binary, you're figuring out which bulb to turn on or off in order to get the number you need in this case. But there is actually a counting pattern in this case. So let's see. Okay, so let's try if you can get this thing right. So at least you get 1, 0, 1, and then you get 1, right?
Yes.
So now you try to add 1 to it. So this side over here becomes 0, 0, 0, 2, right? But in binary, we do not have 2. So we carry the 2 into the next place, right?
Yeah.
So the second bulb over here becomes
2.
No. So the first bulb over here is already 2. Now you carry the 2 to the next bulb. The next bulb is originally 0, which is off, right?
Yeah.
So 0 get increased by 1 and becomes
3.
0 plus 1. 0 plus 1.
0 plus 1.
You're gonna break the universe.
The 1 goes down and it's
No.
1. So it's 1.
There you go.
I said that
So
already.
you have that. and then the previous bulb will just get turned off and turn into 0. So that's how you get
So
2, right?
it's 1
Like
0. That makes 2.
yes, yes. Because remember, the very first bulb means how many ones we have, and then 2 means how many 2s we have. Third one is how many 4 we have, and then the last one is how many 8 we have.
Mm. Okay.
So in
Okay.
this case,
Okay.
okay, so yeah, in this case we reach 1 0 because we just count from 0 1, and then you remember the odometer like clock thing. When
Yeah.
the
Yeah.
first place turns from 1 back to a 0, it kicks the next one, and then the next one turns from 0 to 1, right? So that's how we got this. Now we have
Oh.
1 0. So try like what is 3?
3 is this last one because this is 2 and this is a 1.
Yes,
See?
so toggle it. There you go. So that's how you get a 3. Yay! Okay, now what about
Let's
a
go.
4? What about a 4?
Isn't 4 just this one right here? Because it's the
There
fourth
you
one.
go. You get it. There you go. You get
Magic
it.
school bus.
So the main idea
got me.
is we get from 3 to 4 is we just add 1 on the last bulb, and then the last bulb got carried to the next bulb, and then the next bulb got carried to the next bulb, which ends up with this one. So now 4. Try to make it 5. And also at the same time, I will have to move myself before destroying my controller. There we go. Now try to make a 5 out of this thing. 4 plus 5 should be an easy one. There you go. So yep, you just keep on adding 1.
Mm-hmm.
All right,
I'm a
now
genius.
try to make it a 6.
Okay. If I turn this off, 4, and then add 2 here, it's a 6.
There you go. So that's one way to think about binary as
Not
well.
even once.
Now this one should be an easy one. 7. So there you
7.
go. So here's one of the thing which is actually quite noticeable is every time when you have a number which is a power of 2 minus 1, you will have that number, like the bulb of that number is off, and then the rest of it is on. So in this case, 7 is 8 minus 1. So we have 8 turned off, and then the rest is 1. Now try to turn this into 8.
8.
This is a little bit challenging, but
With all my brain blast powers. Let me start over. Hold up. We got 4, 6, that's 7. Check this out.
there you go. There you go. That's 8. So if we jump back a little bit, we have 7, which is 0, 1, 1, 1, and then you add 1 to the last one. So the last one got carried to the next one, and then got carried to the next one, and then got carried to the next one, and then the rest becomes 0, and then 8 becomes 1. So in this case. So now we can move on to number 9 in this case, which is also a simple one.
Alright, Sharp Razor, you show me how to do a 9.
So in this case, it's like very simple stuff because 1, 0, 0, 0, and then you add 1 to the last one to it. We can turn off that one. So that's actually how you get 9. Now, just in case, some of you might heard of base 16, right? So base 16, you have 16 symbols in this case. But in this case, in normal number sense, we only have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But what is the next symbol in this case? Do you know that?
Yep.
So it's up to you. Add 1 to it. Make this a 10.
Ah. Oops sauce. 8.
8 plus 2, that's 10. There you go.
Oh, I got it right! I knew it!
There
Man,
you
I
go.
thought that was an
so
A.
In this, yes. So in this case, in base 16 or hexadecimal, we started to use letters to represent something higher than 9. So you can immediately guess if 10 is A, you can immediately guess what is 11.
The one at the end
Hmm?
for 11.
Yes. Like, do you want to guess like what is 11 in hexadecimal or base 16?
And this right here.
Yeah. There you
There.
go. So yes. And then in order to make a 12, we can have 8 plus 4, which is C. Boop, boop. There we go. So that's 12 in this case.
Mm-hmm.
And then of course you can keep on moving until you have D, which is number 13. And then you can have E, which is 14. And then for the final letter,
Andra.
which is entirely like F, like full plus F. So this is why sometimes when you look at like color codes, sometimes you can see red is actually just FF and then 000000. So that's actually red in this case. So we have that.
Chat. Mm-hmm.
So here's one important thing that we also need to know in this case, and just in case, I remember I also have another one. So here's one thing.
We can make words.
Sort of. Okay, so one thing that we can notice is actually something like a hexadecimal digit.
That's not.
Oof.
That's not.
Big oof.
So it says of. I said oof. Oh no.
Yeah, fair. So just in case, one thing to keep in mind of is you can notice that a single hexadecimal digit is made out of 4 binary digits in this case, right?
Mm-hmm.
So in this case, you can see 2 and 16. There are actually power of each others. Like in this case, like base 16 is just actually 2 to the power of 4. So that's why you will need 4 binary digits in order to have a hexadecimal digit, right? And this also means that if you have like 2 hexadecimal digits together, or 8 binary digits, or 8 bits, which is a byte, you can have what should I say this? A byte in this case, because in this case you have 2 to the 8 available values, which is 256 possible values. So you can represent from 0 to 255 on these 2 things. And then if you want to describe a color with alpha value, you can have 8 of these. So that's actually how you can have numbers representing stuff. But because different bases let you represent the same thing in a different way, sometimes it is better to like represent some sort of number in a different way. Like for example, like for normal human counting, yeah, fine, stick with base 10. But in computer science and all this electrical engineering stuff, you better stick with binary or hexadecimal or octagonal, which is base 8, or wish you luck. So yeah, we have this thing. So yep. There you go. Now, for the one final challenge, do you want to try counting in base 3?
Razor.
From 0 to 10.
I think I'm up for the challenge. Sorry about my leg.
So just in case, 10 in base 3 can be treated as we have 3 plus 1, right? So in the end, you should be able to get 1, 3, 9. So in the end, you should be able to count to 101 in base 3. Right? All right, let's go. So 0.
To base 3?
Yes, in base 3, count from 0 to 10. Just to see if you get it.
My brain just flatlined. 0,
Yeah?
1, 2,
Yes, yes.
and I'm gonna do 1, 0 again.
Yes, there you go. And then?
Okay. Wait, what are we getting to again? You said 30?
So you have 1, 0, right? And then you add 1 to it, what you will get?
1, 1.
There you go. Now add 1 to
1,
it.
2.
There you go. Now add 1 to
2,
it.
0.
There you go.
2, 1. 2, 2.
There you go. There you go.
Does it just do 3, 0? Or does it like...
Okay, so you have 2, 2. You add 1 to it. What will happen?
It turns into a 3.
So 2,
But-
3. But in base 3, do you have 3?
No.
No, so you carry it, right? So so instead of 2, 3, you have...
Oh! Um... 1, 0, 0? No.
There you go. Now add 1.
I did, yeah! Uh-huh. And then it's
Now
1, 0,
add
1.
There you go. You count to 10. Yay! There you
We
go.
did it!
There we go. So yeah, there we have it. So just in case, if everyone you're watching this to the very end, thanks for watching, and then we'll see you in the next episode. Bye.
Bye!